Hello, in this video we will look at what are hard and soft links and how do we work with them. But before getting into any more details about how to work with them, we should understand what is their function and what do they look like. So the purpose of links, whether it is hard link or a soft link, is to be able to access any file located at some other location. It could be a file or a folder in case of a soft link, but in the case of a hard link, it is most generally used to link to files. But the way in which they are linked is completely different. We will look at how are they different. But before getting into more of that, let's see how do they look like. So let's go to the terminal. Here I have created a folder where I have a few files and directories, and these will be used to demonstrate the concepts that I explain in this video. So I have three folders: directory 1, directory 2 and directory 3. Each of them have a single file named file1, file2, file3.txt. So, and all of them have contents just to identify each of the files. So for example, if I do directory 1 file1.txt, we will see that it is showing this is file1.txt. So this is the only content in file1.txt, and similar is the case for directory 1, directory 2 and directory 3. So this is the basic structure of all the directories. Apart from them, we have two more files. One file is actually the hard link to the file file1.txt, which is inside directory 1, and the second file that is a soft link to the file file2.txt, which is inside the directory 2. So let's go to the file explorer and see how do they look like. So these links look like just like any other file, but the way in which they work is completely different. Usually when you have a soft link, you will see some kind of an arrow, and it is actually marking the way in which this is used to link to the file. So if I open this file, I will see that it is opening the file2.txt, and when I am opening file1 hard link, it is opening the file1.txt. On the surface, they may look like they are doing the same thing, but under the hood, actually different things are being done. And that is very crucial to understand. So whenever you create a soft link, either to a directory or to a file, what happens is a new file is created, right? So file2 underscore soft link is actually a new file that is linking to the original file that we want to link to. But in case of hard link, a new file is not created, but this may look like a new file, but it is actually not a new file. It is a link to the same original file that we have. And we will see that we will verify this by using the terminal. Whenever you store some data in your disk, what happens is there are a sequence of bits, and some sequence of bits represent a file. Associated to any file is some metadata. Metadata is basically data about the data. So you have any file which is data, and then associated with them is some metadata. In that metadata for any file, there are two information that is very important for us. The first information is the inode number, and it uniquely identifies any file or a folder. And apart from that, there is one more information in the metadata, that is number of links to that file or folder in the file system. So there can be just one file, but there can be multiple links to the same file. So let's see what are all the inode number of all the original files, as well as the inode numbers of the hard link and the soft link. So for that, I will do, what has it done is that it has listed the contents of this folder, and along with that also the contents of the folders that are contained within this folder. But we want to look for the inode numbers. So for that, we need to attach one more flag, that is -i flag, and it will list the inode numbers also. So we can see that the first information that is there in the listing of any file or a folder, it is the inode number. So this hard link has an inode number, this soft link has a inode number because it also represents a file. But if you observe and compare the file1 hard link and the hard link for the original file file1.txt, you will see that both of them has the same inode number. So the inode number for the hard link is 3290685, and the inode number for the file1.txt is also 3290685. What it means is that both of these files that we are looking at them as files, they are not actually representing different files. but they are representing the same file in the disk, but these are actually two separate links that is pointing to the same file. And there is one more information that you will see in this listing after the permissions string, and it is 2. It means that this file has two hard links, and that is correct because we have one link that is this original file, and the other link that we have created is the file1 underscore hard link. So it means that both of these are pointing to the same file, but these are just links. Actually, this link consumes very less space in the memory, but these are pointing to the same file. So because of this, what happens is that whenever you open a hard link and you make any changes here, then it will be reflected in the original file. So you can consider it like the file is located at both the locations and they are in sync with each other. So that was about hard link. Now, how do soft links work? So let's compare the inode numbers of the soft link and the original file that it is pointing to. So we can see that this soft link is pointing to the file2.txt, which is inside the directory 2. It has an inode number 3296038, and if you observe, it is different from the inode number of the original file. It means that this file2 soft link, it is not pointing to the file in the disk, but it is instead pointing to a file that is inside the directory 2 and file2.txt. So this file is pointing to this file, and this file2.txt is pointing to the original file. So whenever you are opening this file, so whenever you open the soft link, what happens is that it tries to open the original file, and the original file is pointing to the file in the disk. So this is how they work. So first it goes to that file, then it goes to the original file. So that's how they work. But in case of a hard link, this does not happen, and any link directly points to the original file in the disk. You can also observe that file2 underscore soft link has just one link, and file2.txt, the original file, also has just one links to it, because these are separate files. A new file is created that is a soft link, and it links to the file2.txt. So that was some basic information about hard links and soft links. Now we will see how to actually create them. There are two commands that are commonly used to create the hard links and soft links. The most common way to create a link is by using the ln command, but there is also a cp command that we use to copy files and directories here and there, can also be used to create links. So whenever we are copying some file or directory from here to there, if we specify some flags, it will not copy them, but instead it will create links to the original file. So we will see that later, but first of all, let's see how to work with the ln command to create links. So we have seen that there are two kinds of links, hard links and soft links. In case of a hard link, inodes remain same because it is pointing to the same file in the disk. But in case of a soft link, the soft link points to the original file, and the original file then opens the file in the disk. So a new symlink is created, and symlink is basically another name for the soft link. So how to create a link? You can see that there are 4 uses of this, and all of these are very simple. And I have taken it from the man page of the ln command that you can have a look at. So the first one is the most common, and you will use it a lot. So when you are using this, you don't need to specify a lot of things, but there are 2 essential things that you need to specify. The first information that you need to give to the ln command is where is your target, which is the target file that you want to open, and what is the link name that is going to be. And here you can also specify the directory where your file is located, and along with the name of the link. So let's see at a simple example of how we can create a link. So we will go to the terminal, and we have a few links here. So I will remove these links and create them again. Let's create the same link that was previously there, and I removed them. So the first link that was there was a hard link to the file1.txt, which is inside the directory 1. So for that, I will do ln, then I need to specify the target. What is the target? Target is to the file directory 1, and inside that there is a file called file1.txt. And which is my link? I want the link to be, suppose I want the link to be not in this directory, but I want the link to be in the directory 2, and I also need to specify the name of the file. Even if I don't specify the name of the file, I just keep the directory name, then it will create the hard link with the same name. So a new link will be created inside directory 2, which will have the same name, file1.txt, but I want a separate name, so that will distinguish that it is actually a hard link. So I will do file1 underscore hard link. Yes, so this is created. So I will open it, go here, and if I open it, I will see that this is file1.txt. So it has opened the file1.txt, which is a hard link to file1.txt. And if we look at the contents of all the folders along with the inode numbers, you will see that file1.txt has this inode number and file1 hard link has the same inode number. So this is how you create a hard link. You just write the ln command and you give the target and the location of the link. But if you want to create a soft link, what you need to do is you need to append a -s flag so that it will create a soft link. So for that, I will create soft link for file 2 inside file 3. Sorry, I will create the soft link for file 2 inside directory 3, which will be named file 2 soft link. Okay, now let's open it, and we have this file 2 soft link, and it is a soft link to the file 2. When I try to open it, it is saying that the link file 2 soft link is broken. Why is that? Have we done something wrong? So let's try to list it here. So if I list all the files and folders here, so okay, let's long list. So we will see that this has listed the file also, and it is representing that it is a soft link. So this is listed, but we will see that this is pointing to a file file2.txt, which is inside the directory 2, and it is in the red color. That means that this link is broken. What is going wrong here? We will see what is going wrong here. Just for an experiment, let's do something. So I will move into directory 2. Sorry, let's move into directory 3. So here it is listed. So what it is trying to do, this file2 soft link, it is trying to look for a file called file2.txt relative to its location. So it is trying to look for this file relative to this location, but this is not there, right? Since this directory has just 2 files and no such folder. So it looks like we have made a mistake in specifying the location of the target. So let's just for an experiment, let's create a new directory here and with a new file, and let's create a new file inside directory 2 file2.txt. So let's now try to list it. So the color of the link changes to green. What it means is that it is now able to find a file named file2.txt, which is inside directory 2, and it is looking to the path of the target related to its location. Then it is showing in the green color. But when we open it, let's open this, we will see that this is actually pointing to a different file and not the file that we wanted to point it to. So we will just remove the directory 2 because this was just for an experiment and we did not want to link this file, but we wanted to link the file that is located inside the directory 2 in the links folder. So if we see, this is again broken, so it will not work. What was the mistake? The mistake was that we specified the location of the target relative to the current directory and not relative to the location of the link wherever we want the link to be. So let's try once more, and there what we will try to do is we will provide the link to the target relative to the location of the link wherever the link will be residing. So both of these are being provided with respect to the current directory. But what's the location of the original file file2.txt relative to this file? So for that we need to move one level up in the directory into the parent directory and then go into the file2.txt. So this is the link to the target that we specify first. So for that, if we do this, it means it will search for in the it will search for directory 2 in the parent directory, go one directory up, then look for a folder named directory 2, and then inside that it will try to find a file named file2.txt. So this is how the soft link will try to find it. So let's run it. It says that the file exists. So that is one more behavior of ln command that you need to know, that it will not overwrite any existing file or a folder, whether it is a soft link, hard link, any kind of a file, it will not overwrite it. So for that we will need to give the -f command that will force write it. So if we now list all the files and folders, you can see that it is now working. It has turned into green, and it means this is now a working soft link. So we will go into directory 3, and this is file to soft link. If we try to open it, you will see that it is correctly pointing to file.txt. The learning that you need to take out from this is that whenever you are creating a soft link, you need to provide the link to the target relative to the location of the link where the link will be residing. But whenever you are creating a hard link, you can specify the link to the target and link to the link relative to the current directory itself. But if you completely avoid this problem, what you can do is you can provide links to both the link and the target as an absolute path. But it is not a good practice. Why is that? Because suppose in this case itself, I have a directory called links where I have all of these folders. Now the file that is inside the directory 2, it has a soft link located in directory 3. And if I provide the link to the file that is inside directory 2, that is file2.txt, as an absolute path, what will happen is that if I will shift this links folder to any other place, the absolute path of the file2.txt will change, and it will make the soft link that is inside the directory 3, it will be broken. It will not be future proof. But if I provide relative links, it will always work. So in this case, this soft link knows that I need to go one level up in the directory, then I need to go inside directory 2, and there I will find file2.txt. So this will always be done by the soft link, but whenever we provide an absolute path, it will not be able to traverse to that file. So that is the disadvantage of using the absolute path. But it can alleviate some problems for you, but it will create another problem. For hard links, you can provide absolute paths for both the link and the target, as well as the paths from the current directory relative to the current directory for both the link and the target, and it will just work fine always. But in case of a soft link, the best practice will be to provide link to the target relative to the location of the link itself. So that thing you need to keep in mind. So we have seen very basic uses of the ln command to create links. Now let's see what were all the other uses of this ln command. So if you just provide the target, then what will happen is that the link will be created in the current directory itself. And if you have specified a -s flag, so a soft link is being created, and the link, the location of the link is in the current directory. So even if you provide the link to the target relative to the current directory, it will also work in this case. Looking at the third uses, if you just provide the link to the target and provide the link to the directory, and keeping in mind all the things about relative paths and absolute paths that we have discussed just now, then what it will do is it will create soft link or hard link depending on what are you trying to do. It will create the file inside the directory itself, and the name, since you have not specified the name will be the same as the original file itself. So the name will be same as the name of the original file. Looking at the fourth uses, you can provide the target at the end, and if you want to provide the directory at any other location in the command, then you can specify it using the -t flag. So these are the four basic uses of the ln command that you will see, and it covers almost all of the basic uses of the ln command. There are some other flags that you can look up into the man page. Those are not very difficult to do. Now let's look at how we can create hard links and soft links using the cp command. So this is another way of creating links apart from the ln command. So you must be knowing the basic uses of the cp command. So what we do is we first write the cp command then we specify what do we want to copy. So let's suppose we want to copy the file3.txt, and we want to copy it at which location, that we need to specify next. So we want to copy it at the location directory 1, or let's copy it at the same place. So I will name it file3, and if I list all the files here, and if you see the inode numbers of all the files, both the files, the copied file and this file, so the inode number is 332 and then 4 zeros. But if you see the inode number of the original file, file3, you will see that it has a different inode number. So it means when you are copying a file, it is creating a new file in the disk. But when a new file in the disk is created, it is taking extra space, right? But suppose just for convenience, we wanted to access the file3.txt in the current directory, and we did not want to copy it. Also, what happens that if you make some changes in the file3.txt in the current directory, it will not be reflected in the original file because those are completely different files. But suppose our use case was that we wanted to have file3.txt at the current location, and we just wanted some convenience to access it. So for that, we will need to create a hard link. So instead of copying, so here was the command that copied it. So what I will do is I will just append a -l flag, and appending this flag will, instead of copying, it will create a hard link. But again, it will cause error because the file already exists. So for that, we can again use the force option. And now if I list all the files and directories, you will see that inode number of the file3 copy is 3299402, and it is same as the inode number of the file3.txt. So what it has done is it has not copied the file, but instead it has linked both the files. And you can see that the number of links for both of the files has increased to 2. So file3.txt has number of links as 2, and also the file3 copy. And it will be very helpful if you're trying to access some file which is located at some deeply nested folder, and if you want to access it at some convenient place, for example at desktop, then it will be very helpful. And in this method, the changes will also be reflected. When you make the change at one place, it will make the change at other place. I have earlier said that you cannot create a hard link for a directory, but you can create a soft link for a directory. But hard links have benefit that it is actually representing the same file. Okay, so but in some way we want hard links for the directory, but you cannot do that because it can cause multiple problems for the operating system, right? So your OS will prohibit you from creating hard links between directories. But there is a hack to that, and I will discuss it now. So for demonstrating that, let's create a new folder named directory 4, and I will create a few files inside it. Directory 4. Okay, so we have a few files inside directory 4. Now what I will do is I will copy all of the contents of directory 4 into a folder named directory 4 copy. So -r, we want to do it recursively, but instead of copying it, I want it to create hard links for each of the files. So for that, I will add the -l flag. Then what we want to copy? We want to copy the directory 4, and we want to copy it into directory 4 copy, and it worked. So let's see all the contents. So if you look at it, this is directory 4 and this is directory 4 copy. But if you observe, all of the files in both the directories have the same inode number. So one file.txt has 3671348, and it is exactly same as the inode number in the copied folder. So, and also the links, the number of links for all the files inside directory 4 and its copy is equal to 2. So what it has done is that instead of copying, it has created hard links for each of the files in the copied folder. But let's look at the hard links of the folders itself. So for that, I will not specify the star, and I will just do -li. So if you see, the hard link of this directory 4 and directory 4 copy is different. So the directories are different, but inside them the files are just hard linked. It will be very helpful if you have a folder containing some files and you want the hard link of all of them, but you don't want it to take extra space. So we have seen how if we have a folder and we want to copy it, but we don't want it to take any extra space, then what we can do is we can create it as a copy of all the links. So another copy will be created, but the files will be just links to the original directory, and it will not be an actual copy. So it will not take any extra space, just the folders will take extra space, but the space will be taken very minimal. But this is actually a workaround for a particular problem, that we cannot create hard links to the directories. But there is a very simple way. If we want to access some folder at some other location, we can just create a soft link, right? So if we want to create soft link to a directory, we can just use the ln-s flag. So let's create a soft link to the directory 4 inside directory 1. And if we look at the target, what is our target? Our target is directory 4. And what is its location related to the link where it is going to be located? It is going to be located inside directory 1. So we need to go one level up, and then we need to find the directory 4. And the location of the link will be inside directory 1, directory 4, symlink or soft link. Sorry, I'm using the ls command, that is wrong. Yeah, so let's open it, and if we click on it, we can see that we can move directly inside directory 4 from the directory 1 itself. So it is a working soft link. But keep in mind that these are not any kind of links. Just this folder is a link, and it is linking to the original folder. So these are the original files. Now currently we are inside directory 4. So it is just a convenient way of moving from this place, from inside the directory 1 to directory 4. So this is how you create a soft link to a directory if you want to access some directory located at some other place. So this was all about what are hard and soft links and how do you work with them.